So this is the second case of 2's complement arithmetic, when one number is positive and the other is negative. Okay, but the magnitude of the positive number is greater than the magnitude of the negative number. Okay, this is the condition. Okay, so let's take the case of 18 minus 7. Okay, so here 18 is positive, 7 is negative. Magnitude of the positive number is greater than the magnitude of the negative number. Plus 18 is greater than, 18 is greater than 7. Okay, but 7 is negative, 18 is positive. So first we have to represent them in their binary equivalent form. So 8-bit format we are using: 7, 6, 5, 4, 3, 2, 1, 0. Now first is 18 plus 18, splitting it into powers of 2, 16 plus 2, 2 to the power 4, 2 to the power 1. Respective bit positions, there will be 1 bits, remaining will be 0. Okay, this is plus 18. Then we have minus 7, but for that first we have to represent it in positive format, plus 7. Now here if you see, the MSB or sign bit is 0, which is of course for positive numbers it will be 0. Okay, this. Then in order to represent minus 7, first we have to represent plus 7, then take the 2's complement of it. So plus 7, that is 4 plus 2 plus 1. Okay, so here it is 2 to the power 2, 2 to the power 1, 2 to the power 0. Okay, so here 1, 1, 1, and the remaining bits are 0. Again, sign bit is 0 because it is positive. This is plus 7. Now in order to represent minus 7, we have to take the 1's complement of plus 7 and then add 1 to the LSB to get the 2's complement. So here first we'll take the 1's complement of plus 7. So zeros will be 1 and 1 will be 0. So here it is 1, 1, 1, 1, 1, and then 0, 0, 0. This is the 1's complement. Then when we add 1 to the LSB here, then the final result which we calculate is 1, 0, 0, and then 5 ones. One, 3, 4, 5. This is the 2's complement. Okay, minus 7 in 2's complement form. So now we add 18 plus minus 7. So this 18 minus 7 operation, okay, this one, minus 7 operation, we will convert it into this form, 18 plus minus 7. Okay, so first we have 18, which is 000 100 10. Okay, this is 18, and minus 7 in 2's complement form, which we calculated, 5 ones, then 0 0 1. Okay, so we'll add them. We'll get 0 plus 1 1, 1 plus 0 1, 0 plus 0 0, 0 plus 1 1, 1 plus 1 is 0 with a carry of 1, 1 plus 1 0 with a carry of 1, 1 plus 1 0 with a carry of 1, 1 plus 1 0 with a final carry. Now this final carry, how we handle it, that is very important. If you remember, in 1's complement we take this final carry and add it to the LSB of the result to get the final binary equivalent form. But in 2's complement, this final carry, it is discarded, or we can say ignored. It is not added to the LSB, and this is the final result. Okay, so now if we convert it into decimal form to see the result, we know 18 minus 7, that is equal to 11. So let's see after we convert it into decimal form whether it is 11 or not. So it will be 1 into 2 to the power 0, 1, 2, 3, 1 into 2 to the power 3 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. This is the decimal value, equal to 8 plus 2 plus 1, which is equal to 11. Okay, now both sides they are matching. Again, this is 0, the sign bit or the MSB bit, it is 0, so it means it is a positive number, of course. Okay, so here it is 11, here also it is 11, so this binary representation, it is correct. So this is 2's complement arithmetic operation performing one number positive, one number negative, magnitude of the positive number is greater than the magnitude of the negative number. This is the case.